Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Usman Khan and I am presenting the research paper titled as Exploring the Unchartered Space of Container Registry Typosquatting. The paper I am presenting here consists upon important features of cloud computing and their consequences. Let me start by giving you some background of container technology. Container Container technology such as Docker has been widely adopted in cloud computing, edge computing, high performance computing, and serverless computing. For its favorable multi-tenancy isolation, near native performance, and excellent support on continuous integration, continuous delivery. One of the distinct features is that Docker wraps applications and their dependencies, code runtime, system tools, and libraries into an image, enabling fast software delivery and easy portability. Management policies. In private registries, account owners are charged based on the amount of storage used to host their images and the network bandwidth for both uploading and downloading container images. Usually, each account contains one or more project IDs similar to usernames in which developers can further establish image repositories. The account owner can authorize other users to download or modify the repositories. Some private registries also allow developers to make their repositories publicly available, allowing access to the image without any authentication or authorization. This image shows the downloading process of an image with FQID image identification. Container registry typosquatting. Typosquatting originally refers to a URL hijacking attack targeting internet users who make typing mistakes when inputting domain names. While significant efforts have been devoted to understanding domain name typosquatting, the current definition of typosquatting has been expanded to include more scenarios sharing similar attack behaviors, characteristics such as email typosquatting and mobile app typosquatting. This figure shows overview of container registry typosquatting. In case 1 represents the case of when users mistype the username fields of the FQID, that is Elise instead of Elise. This pull request still reaches the desired hosting registry, but it enters a different username to pull the image Linux. If the image Linux exists in Elise, the CLI will download the image automatically, otherwise an error message will be reported. Therefore, adversaries can intentionally obtain the username Elise to bait users to download malicious images. Also, this type of typosquatting is possible in both public and private registries. In case 2, a cross-platform typosquatting scenario where a user makes a typing mistake in the hostname field. The download request reaches an undesired container registry instead of registry.com. As a result, the user unknowingly obtains a container image with the same name, that is under the same username Elise but from an undesired registry. Threat model. The goal of container registry typosquatting attacks is to distribute malicious container images by exploiting the potential typos made by container users. Adversaries attempt to generate multiple typosquatting FQIDs similar to those of existing benign images. And the goal of attack generate multiple typosquatting FQIDs and bait users to pull images from a malicious repository. Attack benefits generate financial profits, obtain sensitive information of the victim, harvest computing resources of the hosting server, take control over the hosting server. Typosquatting in public registry. Total pull count and daily increases. Linear increase trend occurrence of mistyping FQID is random, multiple delay spikes. In private registry user-defined project, Typosquatting obtain 407 project IDs from Alibaba 1. These are examples of the performance of Typosquatting private as well as public registries. Mitigation. Mitigation is basically the author's proposed crystal model that is a lightweight extension on the existing infrastructure of container registry to mitigate the threat from both container registry and user side. Crystal can be seamlessly integrated into existing container registry platforms to detect typosquatting behaviors and prevent users from registering extremely similar usernames. Working from the user side, Crystal extends the image pull method to provide the typing suggestions and correctness to container users before the download process. Overall, Crystal can effectively mitigate the container registry typosquatting problem with minimal overhead and without changing the current container architecture. In conclusion, let me sum up my main points. Systematically study on container registry typosquatting. Users indeed make typing mistakes when downloading Docker images. The authors have concluded a systematic study on the container registry typosquatting threat. They demonstrated that adversaries can impersonate FQIDs of benign repositories to spread malicious container images. This attack can be launched within both public and private registries as well as across different platforms, posing realistic security threats to the container ecosystem. Their exploitation experiments for public and private registries show that users indeed make typing errors and download unwanted container images. They also validated that a large amount of typosquatting usernames, project IDs, and domain names are currently available for public registration. To mitigate the threat, the authors proposed Crystal that assists container registries to discover potential typosquatting FQIDs and alerts users about potential typing errors when downloading container images. They implemented a prototype of Crystal on Docker CLI and achieved a high detection accuracy of more than 97.5% with low overhead. Thanks for watching my video and with attention. Now I am happy to answer any question or query in comment section. You can also submit your query by sending me email at my email address, that is rkv556@gmail.com. Allah Hafiz.